So now let us see some examples of this aromatic compounds. All right. So in the first example we have over here, we see the appearance of the benzene ring and CH2COH being connected to it. But we notice that this benzene ring is missing an H. So this benzene will not be called as benzene, it will be called as phenyl. And when we start numbering this, so we call this as 1 and 2 because 1 it has this functional group attached. All right. So at 2 we have the attachment of the phenyl ring, and therefore the name of this compound now becomes, so it is 2-phenyl, and then we have two carbons. We have two carbons over here and this carboxylic acid. So we call this as ethanoic acid. All right. The name of this compound is 2-phenyl ethanoic acid. All right. In the second example that we see over here, we have this compound, and here we see that we have this particular benzene attached to an OH. So this is the phenol we can see. And here we can also say that this is a benzene which is attached to this CH2 and we have OH as a side substituent. So we can have two names for this, and the most suitable name will be the one which has this OH as the major functional group and this being considered, the benzene being considered as a phenyl here, along with this attachment of OH at the second position. So what we're trying to say is we give numbers and we see that this here, so we call this as 1 and 2, and at 2 we see the appearance of hydroxy group. So 2-hydroxy. Then we have phenyl over here, 2-hydroxyphenyl, along with this attachment of CH2OH, that is our methanol. Alright, so the name of this compound is 2-hydroxyphenyl methanol. In the third question that we have over here, we see this and we start numbering from here. So 1, 2, and 3. At 3, we have the attachment of this particular benzene ring with the lost H, and here the name of this compound will become, so at 1 position we have chloro, so 1-chloro. Then at 3 we have the connection of this benzene with the lost H called phenyl as we have discussed previously, and then 3-member carbon chain, so we call this as propane. So the name of this compound is 1-chloro-3-methyl 3-phenyl propane. Alright. Moving on to the fourth one over here, we see the appearance of COH over here and another COH over here. So now, what is the name that we'll assign to this compound? All right. So if we clearly see these two are connected to a benzene ring, so we can call this as benzene, and at one position as well as the third position, we have the attachment of carboxylic acid. All right. So at 1 and third, we have carboxylic acid, so call it as dicarboxylic acid. Alright, this is how we name compounds when we know that benzene ring is an aromatic compound and we use that name to name our compound. In the fifth one that we have over here, we have the appearance of two OH group at this and here at two positions. So the name of this compound is benzene again because the main chain is benzene, and now benzene is attached to two OH at 1 and 2 positions, so we call them as 1,2-diol. Now, let us come to some major compounds and let us begin. So here in the first one, we see that here we have the presence of this benzene ring connected to this COH, and we know that we call this as benzoic acid. And we have the attachment of this group over here. So what is the name of this compound? So here the COOH group that is connected, the COH group acts as a principal functional group, and thus the numbering is 1, 2, and such. All right, 3, 4, 5, and 6. And now if we see at 2, we have the presence of this particular group, and we know this group, this is called as ethanoyl oxy. So 2 ethanoyl oxy, and then we have benzoic acid. All right. So this is the name of the compound. Now we can also call this as 2 acetoxy. This group is also known as acetoxy, and we keep the benzoic acid attached. All right. Next again, we can also call this as acetyl, and then we attached salicylic acid to it, keeping in mind all the previous aromatic compounds that we discussed. Alright, and this particular compound, we all must have seen this because this is known as aspirin in layman's terms. So, aspirin over here has three names if we consider naming it through our aromatic compounds. Alright, next that we have over here the second one. In this, we see the presence of this OH connected to this benzene and this ring that is appearing over here, the substituent. So here, the principal functional group, that is the main functional group that we'll be considering, is this group that because it has the highest priority. And now, the name of this compound, so we start the numbering 1, 2, 3, and 4. So this whole benzene it attached to this NH, and here the name of this compound now becomes N. So at N we have 4 hydroxy connected. Also, this is the phenyl ring, alright, because a benzene ring which has lost one H is called the phenyl ring. So 4 hydroxy phenyl, and then we have ethanamide. That is the name of this particular principal functional group. And to the layman, this is known as paracetamol. Alright. So paracetamol, the structure looks something like the second one. Alright. In the third one that is in front of us, we have this particular ring, and the name of this is, so here when we start naming this, the IUPAC name comes out to be methyl 2-hydroxy benzoate. Alright. The methyl we have from here, the benzoate is because of this benzene ring, and at the second position we have this hydroxy group attached. Alright, so the name of this becomes methyl 2-hydroxy benzoate. Now the common name of this is, so the common name to which we are aware of this is the oil of wintergreen. So this is known as the oil of wintergreen. Alright, so these are three compounds that we have to keep in mind. Moving on to some examples that we have over here. So in this first one that we see that we have OH, CN, and Br group attached to this benzene ring over here. So the name of this compound, the numbering firstly, begins from CN. So 1, 2, 3, 4, 5. And 6. Alright. The name of this compound thus becomes, at 2 we have bromo, so 2 bromo. Then at 5 we have the hydroxy group, so 5 hydroxy. Then we have this major ring, that is this benzene ring connected to this CN, and we have learned the name of this ring, that is it is called as benzonitrile. So here we write benzonitrile. Alright. So the name of this becomes 2-bromo 5-hydroxy benzonitrile. Coming on to the second one that we have over here. Now, in this particular one, we have the benzene ring over here and this C double bond O Cl attached to it. So the name of this compound becomes benzene, and then we have carbamoyl chloride. Alright. In this third one that we have over here, we have the appearance of OH, Br, and Cn group. Now here, this Cn will have a priority over this OH, and this OH becomes a site substituent. So the numbering starts from Cn, of course, and 1, 2, 3, 4, 5, and 6. So the name of this compound becomes at 6. So here, in this particular question, we have at 4-hydroxy and at 2 we have bromo. So the name of this compound is true bromo 4-hydroxy, and then we have this CN with this whole benzene ring called as benzonitrile. Alright, so this is the name of the compound. In this fourth one that we have over here, we have the appearance of OH and Br, and we know that OH is what is considered with a ring, and therefore the name of this compound will be, so at 2 we have bromo, so we can call this as 2 bromo, and then this OH phenol. So this is 2 bromo phenol. Alright, or we can say that this is 2 bromo benzenol. Alright, then we have this particular question in front of us, the fifth one, and here we have the appearance of many substituents. So we start the numbering from this Cn because it has the highest precedent over the others. So 1, 2, 3, 4, 5, and 6. So the name of this compound now becomes 3-amino. Then we have 6-bromo. Then we have 2-chloro. And then lastly, benzonitrile. Alright, in this sixth one that we have over here, we have this COHO group attached, and this has the highest precedent over everything. So here 1, 2, 3, 4, 5, and 6, and the name of this compound therefore becomes, so at 2 we have the bromo, so 2 bromo, then at 6 we have chloro, so 2 bromo 6 chloro, and the CHO with the benzene ring is known as benzaldehyde. Alright. In the last one that we have over here, we see the appearance of 3 NO2 groups along with a CH3 attached to it. And therefore, the name that we write for this is, so here we take this as 1, 2, 3, 4, 5, and 6, and we treat this NO2 as substituents and the CH3 as the main chain with the benzene. So the name of this compound is 2, 4, 6. Then we have tri nitro, and then CH3 along with benzene is called toluene. So toluene. So the name becomes 2,4,6 dinitro-toluene. All right. So this is how we name our compounds when we know the aromatic compounds attached to them. All right. So this is the end of the nomenclature of aromatic compounds.